Hi, this is a tutorial explaining how to install the RL language on Windows. It does not explain what the RL language is and how to use it. If you are looking for those information, check out the links in the video description. To use RL, we need to install two programs, Python and VS Code. They can be found online. Let us click on the Python download page. As of the moment of writing this tutorial, RL only supports Python versions from 3.9 to 3.11. Do not download versions that are greater or equal to 3.12. The version we care about, the 3.11, can be found by scrolling down into the page. I will download the Windows installer 64 bits. If your CPU is a ARM CPU, you might need the one below it. Once it has finished downloading, you can click on it to install it. Make sure to check the add python.exe to path, otherwise later steps will not work. While we wait Python to install, let us download VS Code 2. Search on Google Visual Studio Code download. Click on the first link and then click on download. When Python is done installing and Visual Studio Code is done downloading, you can install Visual Studio Code as well. Once Visual Studio Code has been installed, let us make sure it can reach Python. So, let us open a terminal, then in the terminal type python ---- version. It should print the number of the version of Python you've just installed. If this does not happen, it means that your installation is somehow wrong, and you will have to investigate what the reason is. If instead it does print the correct number, then you can install RL. What you need to do is just to type pip install rl_language. It might take a minute or two to install all the packages. Once the command prompt is again visible, the installation is complete. At this point, you can create an RL file if you wish. As you can see, the file we are typing does not have syntax highlighting. This is because we need to install Visual Studio Code plugins as well. So let us click on View, Extensions, and then in the search bar that appears, type RL. The two packages you want to install are those called rl-lsp and rl-language. Once you have done so, you should get syntax highlighting and code completion on your file that you have just created. Once this works, you are done setting up Visual Studio Code, and you can try download one of the examples from the RLC repository. So let us Google GitHub rl-language RLC. Click on the first link, then click on Tool, RLC, Test, Examples, Blackjack. Then copy-paste the entire file in Visual Studio Code. As you see, now you should have proper autocomplete support. And for example, you can see which are the fields and methods of the variable card. Okay, now we need just to make sure that the machine learning components do work. Let us type rlc-learn example.rl-o network. This will output a single folder called network that will contain the machine learning network that has learned to play the file example.rl, that is, the file that contains blackjack. The first time we run an RL program, it might take a while. The second time it might run faster. Furthermore, depending on when you watch this video, you may be prompted to type rlc-fix-ray to fix some bugs present in the machine learning network RLC depends upon. If this happens, just run it once and then run again the command you were trying to run. Once rlc-learn starts operating, you will see it emitting a lot of output in the terminal. This is intended. To see a human-readable result of what is going on, open a browser and type 127.0.0.1:6006. This will display TensorBoard, a web page that will let you see the state of training. At first it will contain nothing, and after a while it will be populated. In that page there will be many informations, but for now we only care about two graphs. The one called episode return max, which represents the maximal amount of points that have been scored by the network, were normalized to 1. So a result of 1 means that sometimes the network manages to score 21 points in blackjack, which is expected. On the x-axis there is a number that represents the time passed since the start of the training. The number is not trivial to interpret, so for now let us just ignore it and just pretend it is time. Now let us check out the episode return mean graph as well. This is not the maximal amount of points that have been scored by the network, it is instead the average amount of points that are being scored. Since the network is learning, we expect this graph to go up. If it does not go up, then there is some problem with the setup. If you wish, you can click on the top right arrow to refresh the page. You can click on the cog as well to automatically refresh the page. When we are satisfied with the training, we can stop it by clicking Ctrl+C in the terminal. Finally, let us visualize what the network has learned. We can run rlc-probes example.rl network to get an insight in the probabilities the network has assigned to each move it can take. We can see that if we run this program, then at some point it will print a human-readable explanation of what is happening. In particular, the first line contains the number 0, that means this is the first move, this is the move 0. It contains the string p0, that means that it is the player number 0 that must take this action. It contains the state of the game, and here in the state of the game we are printing the content of the deck, so we can see all the value of the numbers of the deck, and then we can see the player ends that contains only the cards 7 and 12. Then we can see the probabilities that the network assigns to each possible action. There are only two possible actions. One is called stand, that is do not draw any more cards, and one is called hit, that is get a new card from the deck. In this case we can see that the network thinks there is a 64% probability that the correct move is to stand, and a 33% probability that the correct move is to draw another card. Now the network has not learned enough to provide very good explanations, so for the first part of the training all it will do will be to learn to always stand. Then at some point it will learn that sometimes it needs to eat as well. You can press enter to let the network execute one of the actions at random, weighted based on the probabilities it assigns to them. In this case, since it will select to send, the game will immediately terminate. Okay, you are done setting up the RL environment, and now you are ready to use it. If you wish to read more about RL, you can follow the link in the description of this video.